40 people are waiting currently. So, Andone, 47.
Vidish, you are also recording, right?
Yes, I am.
तो just guys, we'll start by 5:05. If you know your friends who are going to come and have not yet come, please tell them to. Actually, this happens in every online event that we have to wait for 5 to 7 minutes before we get the people in. So we don't want it to get extended like to 10 minutes or so from the next events. It is not generally good to keep the speaker waiting. About the previous event, the website making challenge, we have wrapped up, guys. The certificates are sent. If anyone has any queries, please let us know by today so that we can resolve them. Also, thanks for the kind of participation and support that which you are showing us. Today's event has 181 registrations, so that's really amazing. And also, like today's speaker is like I assume that a lot of you guys know Charmi even before today's event, and you guys are really excited to learn something from her. Like she's an international speaker and an alumni of Ahmedabad University. So also, guys, please avoid private messages unless it is something very personal, because we have a lot of co-hosts and we sort of if you send it to someone, then the rest of us cannot see it, and it is possible that your query takes time to resolve. Even if you have queries during the presentation, please try to keep it public so that there are no repetitive queries, and like that makes work easier for us. Like right now I have 3 queries on my private, and it might have been possible that I did not see it because my screen was shared. Okay, guys, let's stick to the time. Let's start. Uh, just a bit of introduction. Uh, Playing with data and predicting possibilities based on it is Charmi's passion, and it has always made her marveled. From facilitating the first pilot of Google's machine learning crash course in India at Ahmedabad University to delivering tech talks at global stages, she loves to help developers and students who look forward to growing their careers in the field of artificial intelligence. She has worked in the pipeline of the Smart Cities mission of India in the deep learning and computer vision domain at the Indian Space Research Organization. At present, being a machine learning engineer, she is building the next generation document agent to automate the data entry and paperwork involved in global supply chains for gigabytes of structured and unstructured data at shipments.com. Uh, by the way, Charmi is a Google developers expert in machine learning. She is also a mentor of machine learning at Girl Script Foundation. She has conducted or been a part of a lot of community events at the national as well as international level. As you know, she's also an alumni of Ahmedabad University. So over to you, Charmi. Thanks a lot for being a part. Like, thanks a lot for coming today. We are really, really excited to have you here with us. Hello.
Yeah. Thanks a lot, Yashraj, for inviting me today, and the P Club, as well as all the faculty members connected with this P Club and Ahmedabad University. Hello to all the dear participants. Thanks a lot for joining today. Just give me a moment to share my screen so that we can start with today's session on basics of machine learning. So first of all, thanks a lot, Yashraj, and the whole team for inviting me today and doing all the background stuff. Thank you very much for that, because those stuffs requires a lot of dedication and back and through communication and a lot of different things. So Sunday evening, during the vacation. First of all, very big round of applause for all of you for joining today to invest in yourself and to be aware about the field of machine learning. Now, if you have joined the meeting, now it's my responsibility to make you all aware and awake. So let's start with some exciting thing which we are gonna do today, and I hope that will make you guys awake a bit. So this is an exciting time for the day. We will discuss and learn what is machine learning and how it is different from traditional programming which we do and which we have learned in the first, second or third semester of our college. What are the different applications and what are the industries where ML is being used? We'll also go deep into the different classes and variety of algorithms being used in this field. And finally, we'll see the 3D ML pipeline. So that pipeline which can be used to develop the ML project in general, which I call as a 3D design, develop, and deploy. And finally, we have a surprise topic. I have planned a surprise topic for you all, which is not related to machine learning, but I'm not gonna spill the beans right now about it. But if that happens, many of you would get changed from yourself, and many a times I get messages and text from my juniors and from other students that how to get to reach your stage, how to get the milestone which you have achieved. So I'll gonna share my journey and what you can do to be one. Without wasting much time, I hope now the session topic and the things which we are going to cover are, maybe some of you have got interested, and most probably I hope that not all of you would start leaving the meeting after seeing the agenda. So make your Josh very, very high, and let's start with this fun quiz. Okay. So many of you might have done this earlier as well. So, but in chat box, do write the answer of this quiz. What do you think the value of 10 would be? Okay, I'm not gonna be a typical teacher or professor over here, but yeah, I just want to make you guys awake, and I'll relate how this quiz is interconnected with the field of machine learning. So I'm seeing the answer from Manav, Pujan, Shivam. They have written 140. Parsha, Yashil, Yashraj have answered 200. Some of you have answered 100, and I'm getting a lot of different answers. Most of them are 100, 200, and 140. Okay. Yeah, cool. So keep on writing your answers here. And to quickly, I'm not gonna tell you the correct answer right now, but let's see the another quiz. Okay. So again, write your answers for this one. If 1 is equal to 11, 2 is equal to 22, what would be the value of 1, 1, 11? Okay, I can see a lot of you are answering 1. Some of you are answering 121. Now someone has answered 1111 4 times. Yes. Yeah, so the majority is, I guess, 1. So yeah, nice, smart engineers. If 1 is equal to 11, 11 can be equal to 1. But as someone has answered that, we can see the pattern here that we are doubling the input we have to the output, right? If the input is 2, we are just doubling that 2 and copy pasting that 2 times. So for 11, the answer can be 1, 1, 1, 1, 4 times 1. So that can be a correct answer, yes. If 1 is equal to 11, 11 is equal to 1, that can also be a correct answer. And here we can see that everything is multiplied by 11. So 1 into 11 is 11, 3 into 11 is 33. So 11 into 11, 121. So there are 3 different answers, right? And here the correct answer was 200. Check with your friends how they got it correct. So let's have introspection. What we just did, we solved 2 different mathematical puzzles, which were a bit complex, but we used our logic to solve them, right? Think about how you solved them. We had inputs, right? And we also had outputs. 1 is equal to 11. We had input, we had output. 1 is equal to 18. We had input, we had outputs. Okay. And then what we did to get the answer for 11 or to get the answer for what would be the value of 10? We created rules in our mind. We saw the patterns that in the first image, the input was multiplied by itself for 1 times and then it was multiplied by 2. Or in the second image, we saw the pattern that maybe everything is just multiplying by itself or it's being multiplied by 11 or something else. So by watching the input data and the output data, we created rules. We found patterns by ourselves in our brains to get the unknown results. Can machines do this? If you I show that what is the participant of today's session. So most of you are from like second year and third year. So I'm assuming that you have a basics knowledge of programming. So nothing more than if you can write a hello word and see, or if you know a bit of how the computer works. So do let me know in the comments again that do you think machines has the ability, the traditional computers, the addition, subtraction, division programs which we write, do they have ability to find such rules and patterns by themselves? If I give this, if I write a code for this, do you think we can get the answers? And in the chat, I am seeing lots of no, 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 no. Yashil has written that no computer is dumb. I completely agree with you. Yes, they are super dumb because we have to give them a lot of instructions. They just work with our instructions, right? Manav has written that yes, we instruct them to. So yeah, if we write that hard code logic, that 1 is equal to 11 and 11 is equal to 1, then it can be true. But basically, to code such rules and patterns using traditional programming is not possible. But if it's machine learning, it is possible. So a crystal clear difference between classical programming and machine learning is here in this diagram. If we were using the codes and subjects which we have learned so far, we know in classical programming, we give data and rules as an input. We give lots of input data like 1 and 2, and then I give a rule as addition. what would the computer would do? It will add these two numbers. It will add the input data. 1 plus 2 is equal to 3. Okay. But in machine learning, uh, it's a bit different in a way that we are not supposed to find the answers from very first end. We'll directly provide answer to your system, to your model, to your architecture as an input, and we'll give data as an input, and then we expect machine to learn the rules and patterns from that input data and generate rules. What does that mean? In the quiz, we show the data which we had, 1 and 2 and 3, and there were 5, 6 different examples, right? So all of them are considered as data. And we also provided answer that 1 is equal to 11, 2 is equal to 22. So we are giving some of the input data and some of the answers to your machine. And then machine, the way you all found the answers, 200, 121, 1, and so on, by creating rules. We want machine to do the same things. And then once we have the rules, we apply those rules to some other data whose answers we don't know, but then we want to get answer from unseen data, is what machine learning is all about. So did you get my point? If not, let me give you one more explanation of what is machine learning. This time using image detection, some images, okay? Life बहुत boring होती है with text and numbers. So let's see. How can we classify these two images? Again, use the chat box to let me know if you want, if you want to teach a small kid, if you are doing a babysitting and then you want that kid to learn that what does apple looks like and how is it different from a mango. How can we teach a student or a machine or a small kid for that matter? And many of you are writing shape, color, orange can be orange. Yeah, so again, color, taste, yeah. Okay, so if it's about teaching a kid, definitely taste can be a good feature. Taste can be a classifying point between an apple and an orange. But now, if they want to teach these things to a machine, yes, we can write that if the given image is a circular shape, it can be an apple. But here in this image, we can see that most probably both of them are a circular shape, right? So then we can also go with color. Then using very basic image processing libraries or image processing code, we can write that if most of the pixels from an input image are of red color, then it's an apple. And then if most of the pixels of a given image are of color orange, then it's an orange, right? But now, what if we have grayscale images? Again, let me know your answers and your thoughts. How would you write a program to identify, to classify these two images? What can be the differentiator features now? Someone has written that apple has unusual shape on top and bottom. Yeah. Many of you are writing that texture and shape. Fantastic. So this is a thing which now our brain and we are learning that how can we see and differentiate two different things. So definitely if the texture is a very smooth surface, it's an apple, and if it's not so smooth but a roughy surface, then it can be orange. And if there is a bit of a branch over here, it can be apple, or so on. So we can code these things, right? We learned that using colors, we can classify these two images. In case of grayscale images, we can use the texture as a property, as a feature. But now, what if I go crazy and keep on adding each new fruit or any food item or whatever thing you can imagine in this world? what will happen now? We would have to rewrite our code every time. We would have to re-engineer the features. Firstly, you had just two images, just two different classes. So you just thought about, you put it aside all the things in the world and just focus on these two things. If something has most pixels is a red, it's an apple. If not, it's an orange. But now in case of a mango, this has like a 50-50%. And there are a lot of different kinds of mangoes as well, which can be of an orange color, which can be of circular shape, which has a similar texture as an apple. So this is like a never ending process. If I want to create a model for, let's say, 1000 different fruits, imagine, will you be ever able to get the differentiator features for each of that fruit, that if they are like if else, the code would have like thousands of lines, and it will be nearly impossible for one to get all of the differentiator features between 1000 fruits. But all of this is being solved using machine learning. But before that, this example was a bit complex, right? Because every input were kind of a circular shape and was a food item. But now, what if we have input images like dog and a mop? Creating a classification model of these two images would be really easy, right? Because a mop would not have eyes, nose, tongues, teeth, and we can get a lot of different things which are specific to one class, which are not at all present in the different class. So dog versus mop is a easy example for a classification as compared to the fruits. But actually no, in real life we can get a lot of different variety of dogs, of a mop. And even for human eye, it is difficult to understand which one is a mop and which one is a dog. So how would we ever able to teach machines using traditional and classical programming? Giving you some more examples of this confusion. See, on the top, there are some cupcakes and faces of some dog, which are looking very similar to each other. How would you get features for this images? Here, there are some chicken sticks and some dogs, which kind of look similar to those sticks. So getting a feature for these images is also difficult. Giving some more example, Donald Trump versus raw chicken, or a parrot versus, I don't even know whether that's some eating item or some chilies. But these images are very similar looking, and this do happen in real life. So this is like really difficult to write using our traditional programming language. In classical programming, we have to explicitly write rules, and that only gets updated if we, keep on having a better and better algorithm. But in case of machine learning, system learns these patterns from data, from input data, and then the improvements can be from additional data. So once you have trained your model on 1000 images of apples and 1000 images of an orange, and then when you productionize this system, and maybe you can create a mobile application, a very small easy example. I want to create a mobile application which can do object detection. So if I take my phone and I open the camera, and if I put it in front of a laptop, it should say me that this is a laptop. If I move it around and show a pillow to it, it should tell me that it's a pillow. Okay, so a classification again, but on real-time camera, on real-time video. So that's known as object detection. So in that cases, that can be possible that the laptop you use is quite different from the laptop which I use. The size of the keyboard, the size of the screen, the keys, how they are located can be different, right? So it is not that once trained your model, it will only and only reuse those patterns forever. Then you can use the output data all of the so when you upload that app on an app store, on Play Store, lots of students will download it and use it on their day-to-day basis. And then the images which those students, those users are capturing, you can reuse those images again to train your model. So you will have an additional data set. And then now you just don't have an image for the laptop which you use, but now you also have a laptop which I and lots of other users use. So improvements in your algorithm, you are not supposed to write any code again to have that mango category, to have that 1,000+1 category. Using just the images, the machine, this dumb laptop or a computer would be able to recognize that. That's what the power of machine learning is. And now, artificial intelligence, machine learning, deep learning, all of these are very interchangeably used words. Maybe people don't know the real difference between them, or maybe there's just no difference. But I will give you a simple definition for each of these three different terms, which are kind of buzzwords which we listen on our day-to-day basis. As we can see in this diagram, artificial intelligence is a big bubble, a big umbrella, and machine learning is a sub-part of it. And then deep learning is a sub-part of machine learning and artificial intelligence. In artificial intelligence, we try to make machine as intelligent as we are. The way we process the data, the way we create the rules, the way we see the world, take decisions. If you are watching any movie, or let's say a series, which is, of a 10 episodes long series, okay? So we have a power, we have the ability to remember some of the scenes from the very first season, and then we can very well connect the dots between all of the different episodes of that series, and then finally we can combine, we can merge the understanding from all of those scenes. Or if I ask you a question that what you had lunch for today, or what did you do at your last birthday, or which was your first school, you would be able to remember the answers, right? But if I ask you a question that what you had for dinner on 5th of May 2020, it's possible that you don't remember. Or if I ask you a question that which was the first place you went on in the year 2011. So our brain has the ability to very fantastically remember some of the scenes and discarding some of the memory, and then reusing the knowledge which we have on the next coming days, on the next coming events, the things which we read in our college during the tutorial sessions or during the assignments. But then we can connect the dots that if this equation can be applied on question number 1, the question number 2 asked in the exam is quite similar to them, and how? Let's see if we can apply that or not. So all of the decision making power which we have, if we try to give it to a machine, it's known as artificial intelligence. Telling you very frankly that there is not any of the machine learning or deep learning algorithm is such today which has the power to mimic the human brain exactly. We are still so many years, there are a lot of years yet to have discoveries on our machine, on our brain, and then coding all of that stuff till we get the real intelligence. But we are going to that thing step by step every day using a field which is known as machine learning. A subset of AI which just use mathematical equations, the subjects which I have learned in my college, or you will be learning in the frequent semesters: linear algebra, statistics, calculus and differential equations, probability and random processes. Just by using these mathematical functions, the statistical method, the examples which I gave of object detection, image detection, or we will see a lot of different examples today during this session as well. So having this intelligence, giving this intelligence to a machine using some of the mathematical method, which is known as machine learning, and we clearly see the difference that if we have an input and if we have the output, and then we give that to a machine, and then using the statistical method, the model's task is to understand the pattern, find the pattern, and then use that pattern on the unseen data. Is what machine learning is all about. And deep learning, fast growing field, an early age field, but has a really high power and ability to solve all of these applications, which can be solved using ML. They all can be solved using DL as well. But there are computation requirements which are quite different in case of DL. The input data requirements are a bit different as compared to ML and DL. So both of them can resolve most of the tasks which we came across on a day-to-day basis. But in case of deep learning, we directly try to mimic the human brain, how we think and we process the data. The way, if you have ever understood the biology behind the human brain, the bioinformatics field, or how the neurons in cell we have in our brains. So a neuron will get some input data, it will process it and get the output. The cells, thousands and millions of cells which we have, we try to code all of these things, which is known as DL, which is a subfield of machine learning. And this all are kind of a buzzwords from nowadays or from since year 2015, since I joined the college. But all of these fields are here in this world from mid 1990s, from early 1990s or 1950s. Remember when IBM created the first robo machine, which defeated the world champion in the game of Go? That happened very early, like before 50, 60 years. The first chatbot, today we use Siri, Google Assistant, Cortana. They are our personal assistant. They can understand our speech. They can understand our text data. All of those personal assistant, a chatbot. The first chatbot ever built was maybe in the year of 1969 or something, or 1962, developed at MIT Labs. The name of that was Eliza. So all of these things which we are understanding today, or which are very hype today, were present before as well. But what is the thing which is making all of these fields becoming a hype nowadays? I will tell you three things. The computation power which we have versus we had in the year of 1950s or 60s is much, much more higher. Remember the Moore's law you studied in maybe third or fourth semester? Every 2 years, the amount of transistor can be put it on the unit area doubles every 12 or 24 months, right? So the CPU, which we had in the 1950s versus graphical processing unit and tensor processing units, TPU, which we have and which are really very handy. That is one of the factor behind these fields to pick hype nowadays. Next thing, data. All of us use Twitter, Facebook, Insta, emails, and whatnot. We generate unstructured data on a day-to-day basis. When you upload text, when you upload an image, or when you do a post or post a video, all of those data are being saved somewhere in the cloud, in Google Cloud, in Amazon Cloud, or in Microsoft Cloud, Azure, right? So the amount of data which we have today versus the amount of data we had in early 90s, there is no like a function which can define that what billions and millions, gigabytes and petabytes of data are being uploaded on YouTube every day. So the amount of computation power we had earlier the amount of data which we had earlier are increased nowadays. And the last thing behind the advancement of this field nowadays is community contribution, the research work, the open source, right? Most of the applications which we code, we write, we upload them on GitHub, and we can very easily see how the researchers from MIT, from Stanford, from Cambridge maybe, doing the stuff which we do, how people in the other country are doing. So the availability of the research papers, the algorithms, the outsourcing of the knowledge is being bit advanced nowadays. That's why ML and DL fields are kind of a buzzwords nowadays. But just make sure that this is not something which come from nowhere, just like 4 5 years. But researchers are working on this field since so long. And now, going a bit deeper into the field of machine learning, there are majoritarily 3 different classes or 3 different types of problems which can be solved using ML. The first one is supervised learning. The next is unsupervised learning. And the third one is reinforcement learning. There are a lot of other fields as well, like semi-supervised learning, but I'm not gonna go deep into those stuff, but let's understand this diagram today. In case of a supervised learning, it's like learning in front of a teacher in a classroom. Teacher teaches students something and then students learns out of that. What does that mean? I talk about images, when we give images as an input to my model and also the output class, I first of all give input to my model an image of an apple, and I also explicitly tell that this is an apple. This is the class where this image resides. And then let my model learn from this data and this label and then predict the answer on 10 more images of apples. So when you provide the output label as well as the input data to your system, it becomes supervised learning. In case of unsupervised learning, just the difference is that we will not give any of these labels. We will just throw away 10,000 images of all of the fruits are being seen in this world, and then let the model understand by itself that these 5 images are looking similar. These 5 images have a similar structure, similar color, similar shape, similar size. These 20 images are very different from these 5. So if you want your machine to create clusters, the different groups of these input data, then it becomes unsupervised learning. In case of unsupervised learning, we will not give the labels, the output labels explicitly to the machine. Let the machine define the classes, let the machine define the rules and patterns. And finally, reinforcement learning, the Atari games which we were used to play during our childhood, or Mario, or some of the games, or a maze runner for that example. At every step, we may have 4 different choices to go. Whether I want this Pac-Man to eat that bubble from right-hand side first or left-hand side first, or from top or bottom. At every step, that agent, that Pac-Man, has to take a decision that whether I should go top, bottom, left, or right, based on the environment, based on those enemies, or fighting with those enemies, or predicting the perfect guess, the correct guess. In case of reinforcement learning, there is an agent to which we give, again, in case of reinforcement learning, there will be just input data, there will not be any labels, similar to unsupervised learning. What was the difference between unsupervised learning and reinforcement learning is that on every next decision taken, if I'm playing a Pac-Man, and if that Pac-Man goes to the right, and then if that enemy is just the besides of that thing, then there's a high chances that I will lose this stage very quickly. So I will give negative points to my agent that, this decision is very wrong. You should have not taken this decision. Or if I win a stage, if I win the game, I will give positive reinforcement to my agent that, yes, very good, this decision was very perfect. The move of the bishop on this chessboard from here to here is really very perfect move, because due to this move, now the chances of winning this game, which were like 60% earlier, are now 62%. So on every next decision taken, either I will give positive or negative points, or in terms of machine learning reinforcement, to my agent, so that in the environment in which it is playing or in which it is created, it can go ahead and ahead and ahead creating decisions. I just talk about the games, but reinforcement learning can be used on trading, on time series data, forecasting. So if you have known the stock price prediction example, using the past historical data of how the Apple or ONG's stock price were from the last 5 years. And now if I want to predict the price of those stock tomorrow and day after tomorrow, I can create an agent on that example as well. Okay. And going now into more deeper, we understood what is machine learning. We understood what is supervised learning. It is like learning with a teacher. Unsupervised learning, learning without teacher. Self-study, independent study period, right? That is what unstructured learning is, just for AU students. And reinforcement learning, when we give positive or negative reinforcement to our agent. And then using supervised learning, there are two different kinds of set of problems which we can solve. One is classification and the other is regression. Classification means what we did earlier today, classification of apple or an orange. So image classification, customer reaction, in case of text data. Okay, if you want to build a sentiment analysis board, that whatever the text I have written, whether it's a positive class, whether it's of a neutral or negative class, what is the sound of this text? Whether I am very angry while writing this text, whether I'm using the words like hate, I don't like it, I'll fire you. So the negative words, if there are a lot of negative words in my input text, then it can be classified as a negative class. Versus if I'm writing something like, today I had a really good session at my alma mater, I got really good feedback from participants, from the organizers, and the day spent well. So this is an example of a positive class. So classification can be of images, of text, of a video. If an input video is the player playing basketball or rugby, right? And in case of regression, it is the example which I gave of stock price prediction. It also comes under the category of regression. If you have some amount of data and then you want to predict the future value, giving you a simple example of temperature. If you know Ahmedabad's temperature of last 5 years in July month, or maybe what was the temperature since last year on 5th of July, I can have an average or a logic that what would be the temperature in Ahmedabad on 5th of July 2021. Just not the location, but I can use a lot of other features like what was the humidity level, what is the pollution level, how is the air pollution index, what is the population of the city. That can also affect the temperature, right? So having this, all of these different features and the geography, or in case of stock price, we stock price depend on lots of things which are happening around the world. You have to be aware about the recent news, the world news. So maybe if you have a data of stock price, also you have a data, scrap data from different websites, that last year due to Brexit the stock of this got down. this year, due to Indo-China war or maybe due to COVID situation, stock market gone below for 5,000 points. So using all of these features, if we want to predict the next value of something, it can be categorized as regression. In regression, we will find a similarity between the past values and the future values. In case of classification, we we search for what are the separators between two, three different things. And then in case of unsupervised learning, as mentioned earlier, we will just give input data without labels. And then model's responsibility is to cluster the data, is to find the different groups. Very good example, during this work from home situation and this vacation period, uh, we all of us will be surfing Netflix, Prime, YouTube, and different streaming platforms. And then once you have seen one movie, they will give you hundreds of different recommendations. Or in case of online shopping on Amazon, if you have searched for a pant or a laptop or a pen drive, they will recommend you that a person who bought pen drive has also bought wireless earphones or wireless headphones. So how does the recommendation system works? They have internal logic that, first of all, while they were learning, they check the user pattern that the person X was surfing Netflix for 5 years, for 5 hours yesterday, and then he showed 5 movies, and all of those 5 movies were of class, action, and thriller. Versus a person Y who was also watching Netflix yesterday, who served 3 to 4 different movies. First of all, he watched a trailer of a movie which was the class drama. Then he show a similar, but then maybe he just stopped that trailer from in between and moved to some other movie which was uh, characterized on the same hero and the heroine. Okay, so the first movie, which was a class drama, that person didn't watch, but whatever the hero and heroine were present in that movie, he showed the other movie which was a class, let's say, romantic, of that couple, and then he did watch. So we can get the user habits from this data. If the person X loves thriller movie, we can recommend more and more thriller movie to that person. If a person is fond to watching documentaries, once he has watched 2 or 3 different documentaries, we can recommend 3 or 4 different documentaries as well, which other people has seen before him. So that's how recommendation on Amazon or on live streaming videos work. And I'm not gonna go deep into the big data thing and how the dimensional reduction is needed, because this images and videos are of GBs and requires a lot of memory. So not all the machines can work and can be trained on this thing. So we have to sometimes reduce the dimension of the data, which all of that thing you will learn in the course of linear algebra. So um, do understand the course clearly to understand more this thing. So now I'm going to the one of the other category or one of the other subfield of AML, which is natural language processing. In that case, we just work on text data. We do not work on images, videos, sounds. So Siri, Alexa, Cortana, they work on sound. They can understand the signals which we are processing. Sound is a signal. Digital signal processing again. So not all of these things, but to get understanding of a language, of a human language. And then there are a lot of different applications of NLP as well. First of all is chatbot, which we discussed earlier. The next one is machine translation. Have you ever used Google Translator? When you don't know the meaning of some word and you want to convert that to your native language, it can be Gujarati or Hindi, Odisha, Chinese, Japanese, whatever. So when you are giving the input in one language, and then you want that machine to convert that sentence into some different language, which is known as machine translation, which Google Translator works on. Then giving you more examples like uh, if an email is a spam or not spam. Gmail does for us for free. But what do you think? What would be the features between classifying whether an email is a spam or not? Using the text data, using some of the words like if an email contains a line that congratulations, you have won 5 lakh dollars rupees or something like that, or congratulations, you have won a lottery, or if the email has a lot of special characters written or a lot of emojis are present is in an email, then there's a possibility, high chances of that email to be a spam. Giving you more example how Google search works, I can ask to get a one answer, I can ask the question in 5 to 6 different manner. If I want to understand that which is okay, if I ask Google, if I do Google search that what are the universities in Gujarat which provides ICT engineering course, and then I can get a list of colleges, Ahmedabad University, DICT, LJ, and so on. Then again, if I ask a question that what are the best engineering colleges of Gujarat, there is a possibility that I'll get again the same list. Then if I ask the question that where is Ahmedabad University located, or where is GICT building, or which area of Ahmedabad, east, west, north, south has Ahmedabad University. So understanding these words, these phrases by a machine to know the sentiment and the semantic of the sentence, that whether the question I asked earlier is connected to my next question, whether I say a sentence like Ram is a good boy, he is very clever. So here the word he maps to Ram. How can we make machines learn that these two are two different sentences, but the character named Ram present on the first sentence, the he in the second sentence are correlated? So doing this kind of stuff on languages is known as natural language processing. The next one, computer vision. Apart from images, some of the examples of this field are detection of helmet using the street light cameras, which we here have in Ahmedabad, or here in this GIF, if we can see that this model is trying to predict what is the number of truck, mediocre sized truck and a car going and coming in this road. So first of all, you can see the red color bounding boxes. So the first thing happening from this camera is that it is detecting an object, a moving object. It is not drawing box in this area where there are trees, where there is a road, or where there is some road signs, but it is first of all identifying that whether this thing coming over here is three of this, whether it's a car, whether it's a truck or a mini truck, whether it's a going or whether it's a coming, and what's the color. You can do a lot of other things on using this thing, but a simple example here is just the counting. How many of trucks has been passed on Nabrangpura Charasta yesterday? So that's one of the examples of computer vision field. Some other examples, one which I asked you earlier, to have an application of object detection. Imagine if you want to create an application from visually impaired people, blind people, who do not, who are not able to see the things which we can see. But what if we can create an application for them that if I point my camera to a bottle, it should speak bottle. So what would be the pipeline for that project? First of all, object detection. Real life images can be cluttered, right? There can be a bottle and a bowl and a bag present very nearby. But then there should be a classifier that this thing is a bottle versus this thing a pillow. And then understanding with the confidence that yes, there is in this image, there is a bottle, speaking that to a person for a visual impaired people can be a fantastic, a beginner application for you to develop. Or if you want to combine more fields, like you want to work on speech, you want to work on text, you want to work on images, what can be the application for that? So think that now I have to develop an application to which if I ask a question that is there a bottle present in this image or in this live video? So I asked a question, and I asked a question. This time I didn't type it. So first of all, I had to create a model which can understand my language. Then once understood, converting that voice signal to something which machine can understand, then decrypting that thing to understanding that this person is asking whether there is a bottle or not. Then you will get an input to your model that check if there is a bottle present in this image or not. And then if it gets a yes, give an answer using a text or using a speaker again that yes, there is two bottles present in this image. So question answering system, visual question answering system is one of the applications where the field of natural language processing and computer vision is interrelated, is interused. And speech understanding is also what all the our voice assistants work on. They try to understand the natural language, and just not in one language, but they are capable to understand a lot of different languages at a one go. A few more ML use cases. This is not even a tip of the iceberg. ML use cases are in almost all industries. Taking an example of medical or education, infrastructure, even in the field of architecture now, ML is being used, or during finance and medicine. There are a lot of use cases. Some of them which we discussed, some of them are written over here, like a self-driving car by Google or by Tesla or by Facebook. Imagine how many different kind of sensors they would have for input. Would have a lot of cameras. Then using the IoT and embedded system design fields like that, they would understand whether the person is coming near to me, whether the signboard is telling that there are two pathways, either I can go to the left or to the right. Or how is the light blinking on the traffic light, whether it's a red light? Oh, I have to stop my car right now. Imagine how many different kind of things a car would have to learn before going to the road. If has to have identify what are the pedestrians are on the road, because a self-driving car should not go on a pedestrian road and kill a few of them. So to first of all learn what is the land on which I should go, then what is the distance dog running nearby me, how should I, what should the power of my brake, whether I should have a short brake or whether should I just decrease my speed from 60 miles per hour to 40 miles per hour so that I do not kill that dog running on the streets. Then what is the signal light, how are the signboards, and how are the other cars are going and coming. And then if to find a shortest path between two of the places, what is the traffic in the all alternative paths, how are the roads, if there is some construction work going on in one of the paths, so let me take the another path. But oh, there's a lot of traffic over here which I can sense from Google Maps analytics data, so let me take some other different path. So all of this decision making on real time, the self-driving car which has to take is dependent on the field of deep learning, machine learning, computer vision. um, Social networks, I talk that sentiment analysis of chatbots in case of cyber security. If you are using a credit card and let's say your using habit is like you do not use more than than 5,000 rupees per month every since last 10 months, and suddenly in 1 month you use 1,50,000, the whole credit card limit which you had, you used. This was not very similar habit which you had earlier, because since last 2 years the model was learning that this person just uses 5,000, but now he is using 1,50,000 in one go. There can be a case that this card has been stolen by someone else and that person is using it, whether it's a fraud data or whether I should alert the user, the fraud or non-fraud, whether this transaction is a true or can be a fraud. So in case of cybersecurity, there are a lot of different applications present. Um, so I talked about a lot of real life applications, which we do use in our day-to-day basis, but there are a lot of fun applications as well, from where you can get motivation to, start your career in this field. So I have put a lot of different applications in my slide, which I would love to all of you to explore by your own. After this session, I will share this deck with you all. But till then, let me just give you some of the examples that um, apple versus an orange is known as a binary classification task. You just have two different classes. But what if you have so many different classes? So the classification thing is known as multi-class classification problem. And now, even if you don't have any coding experience beforehand, still there are a lot of different platforms which you can use to create applications and deploy those on your websites or on your mobile devices, on your end devices, on your as a web application. So this teachable machine and experiment created by Google is one such thing where we can create these models on custom images. I don't want to just use the images which I can get from online, or just, that boring examples of fruit classification of dog or not dog, or dog versus cat. But I want to do something by my own right now. So here is a fun application. In just 2 minutes, I will create a system, a model, which can classify whether a person is wearing a mask or not. So, in the recent days, in the case of the COVID situation where we all are supposed to wear masks, you might have seen a lot of different applications or videos on LinkedIn or on Twitter or on Facebook that different organizations are working to create such models that if the person is not wearing a mask, how can we alert them in a public places? So let's create one such model by ourselves in 2 minutes on the custom data. For that, I'm going to this website and I'm just uh, using the webcam. I'm creating this images. Okay, so you can see that while I'm speaking the thing, it has taken 89 images of myself, which are here, like my hand is being shown in the image. Here my hand is not visible, which is completely okay. And I did a small mistake that this data set is of no mask. I'm not wearing mask in this image. So I labeled my examples. Remember, we were talking something about labels and input data. So here we generated input data, and here we now using this label, the machine will understand that all of these images are class of not mask. And now let me quickly wear the mask which I have with me, and then in this category, now again I am moving my head here and there to just get the different orientations. And like in a fraction of second, now I have 90 images of myself wearing a mask and 89 images of me not wearing a mask. Now I just pressed on training button, and now in just 15-20 seconds the model will learn from these input images, and then on the real time we would be able to test that. So then I'll again wear a mask, and then we will test that whether the model has learned all of the things in a correct manner or not. So if you have some of the background knowledge about the deep learning field, and if you have ever developed some of the projects, you might have come across epochs, batch size, learning rate, such hyperparameters. So I'm not gonna go into details of these, but on this side, you can also change this thing. If the model accuracy is not so perfect, I can change the epoch from 50 to 100 and then retrain my model. I can change all of these things, which I'm not gonna do here. And here, in just a few seconds, the model has been trained, and now on this real-time video, the model is predicting that in this input image, I am not wearing a mask with 100% confidence. Now let me wear a mask again, and it changed to 100% with mask. And now if I just move that mask out of my face, but in the input frame, it is still saying that there is a mask present. Now if I just remove that, it's saying that there's a no mask. See how confidently the model is trying to predict that whether there's a mask present or not, or whether I am wearing a mask or not. So such kind of applications which you can also create. You can add more classes. So mask versus not mask is again a binary classification model, but if you want to train something like mobile phone versus a tablet versus an iPhone or whatever you have in mind, so you can add more and more classes to that, and then you can create models for that. And once you click on export model, you will get your model learnings, and then you can deploy it on your mobile phones using TensorFlow Lite. So you can create a simple mobile application which can recognize whether the person in this image is wearing a mask or not. Or if you want to create a web app, so using TensorFlow.js, you can do that thing. So do explore this teachable machine project by your own, and then tweet your experiments, or do let me know if you think they are shareable. There are two different kinds of problems which you can use are also present. One is a voice recognition. You can either play Arjit Singh's songs in one class, and then maybe Neha Kakkar in another class, or Justin Bieber in another class, and then you can create a model that and then play the next song, which is you can create you can have like the voice identification model using this, or whether there's a lot of hatred in the speech, or whether there's a surprise and happy emotions in this voice. So gather data of person speaking some good things versus person speaking very harsh words, and then once you train the model, you can test it on your data. um, I have put a lot of different examples which I won't go into detail right now, but you know, this is one such examples where I am playing against a machine, and my task is to draw a frying pan, and then using neural networks on my doodles, on the sketches, this model is trying to predict that whatever the I'm sketching, whether this is of something or not. Now it's giving me another option to draw hockey puck, which I'm not going to do right now, but do explore these experiments which are not of just games, or okay, one assignment for you. If you have worked on Arduinos, in your third or fourth semester, and I gave you an example how to simply create an image classification model. Here is an excellent do it by yourself experiment of a marshmallow versus a cereal. So using an Arduino board, there is a whole tutorial how to do that mostly. And here they are giving, so here so they have a just small hardware put over here where they are getting either marshmallows or cereal, and then they have created, this hardware to put this input thing to one of the bowls. So such kind of, amalgamation of not just machine learning but then IoT, you can explore by your own. Music generation is also one such thing which people are working on extensively. This one is one of my another favorite experiment, where using just your physical activity, you can have your own orchestra. So um, if I just quickly play this video, you can. Did you notice how they created this fun application to recognize the human postures, that if the right hand is going up like this, uh, generate a sound of violence, or if they are floating something like this, turn on the piano or saxophone or whatever the music instruments they had. So not even this, but another example of pose detection is when we create when we make robots, or this 5 6 lines to dance the way we dance. So there is a robot, a virtual robot, and the way you flow your hands and legs, that model, that posture also get learns how to dance or how to generate music out of it. So these are all the fun innovative ways, uh, something non-boring stuff of which you can explore by your own. There is a really good example here where you can select different features to differentiate between pizza and non-pizza, the classification model, the Arduino project which you can create by yourself, the sketch RNN model, try it yourself, how do they work, the music generation game, the game which we play, it is really similar to that, but here on your every step you can listen a tune, a melody of a song, and then to listen a whole song, a whole medley, you have to just complete that level. And here are some more links, and there are a lot of different experiments on text data, on videos, on audios, on hardware, which you can see and get inspiration from that for your next project, or how to just start your contribution in this field. I hope now you all have understood what is the field of machine learning, how it is different from the traditional programming which we do, what are the applications, what are the different subfields of ML, and so on. Now, we discussed a lot of different applications today, but to create any of that, there is a simple 3D pipeline for creating any ML project in general, which is first of all designing part of your model of your problem. understanding the problem, gathering data for that, understanding the structure. If it's an Excel sheet, okay, not any fancy video, any fancy sound, but you just have an Excel sheet of your roll numbers versus your grades in each of the semesters or on each of the subjects, and then you want to create a model that whether the student will pass the next semester or whether the student will fail the next semester. Okay, just playing with some numbers, some Excel sheets. How to understand those stuff is more on mathematical stuff, on equations, and I discussed that. First of all, you have to understand that whether the problem which you want to solve is a regression problem or a classification problem. Do you have enough data to train a deep neural network, or you just don't have much data and you don't even have the labels? So whether you should go to some clustering algorithms. For each of these categories, there are hundreds of different algorithms. You can go to the code online for free. You can get hundreds of tutorials, courses, blogs written from which you can understand those things. And obviously, books are there to help you whenever you are not understanding something. But which algorithm to use out of all of those thousands algorithms out there? So MNDL is always a trial and error approach. So maybe key nearest neighbor algorithm didn't work and you may try a random forest. If that didn't even work, you tried a convolution neural network. If that even failed, you go to a decision tree. All of them are different algorithms. And on your data, how to tune the parameters, how to label data, how to convert these images and these sounds to something which machine can understand, because the computer can only understand ones and zeros, right? Binary system. So how to convert the images into a binary system? Images are a combination of a pixel, and those pixels would have three channels: RGB, red, green, blue, and then there will be a value, a number, that for this particular cell, the value of R is 255, the value of G is 50, the value of B is, let's say, 0. So converting that image to numbers so that the machine understand and learn from those numbers. It's what the pre-processing stuff you would have to do in case of a text data. Machine would not understand whatever the language which I have written over here. So in those cases, you might have to create a dictionary of mapping each of the letters or numbers to some different number. Like there is a capital L in this text, and there is also a second alphabet's L present. So whether there should just be a single mapping of capital and small l? No. You might require one mapping for representing this word, for representing this character. And once you are done with converting, okay, and giving an example of a sound, how to convert sound into something meaningful which machines can understand. So ever heard of spectrograms and sound graphs? So the way, the pitch we have, the voice fluctuation we are having, you can also generate an image of that, the blue, yellow, red colored fuzzy sound waves, if you have ever seen. So once you have the conversion from sound to image, how the spectrogram looks of this uh, this paragraph. If I'm reading just that, let's figure out the 3D ML pipeline, you recorded that sound and then you convert that sound to an image, and then you create a deep neural network to classify whether Charmi is speaking this or Yashraj is speaking this. Then you can do the image analysis. So gathering data, analysis of that data, finding which best model would work, and then finally deploying so that our clients can use is what well-known pipeline for an ML. And just going a bit deeper into that, these are mainly the words which consist of this design, develop, and deploy cycle. So look at these words for a minute and then let me know which should be the very first step for developing any of the ML application. Whether I should start with model validation or whether I should start with feature engineering first. Out of all of these 10 steps, what should be the first step of my pipeline to create any ML project in general? Let me know in the comments. Yes, I'm seeing some of you are writing data acquisition. Keep on writing. Yes, so super. You guys are really quick learner. So I gave you a brief introduction of the ML pipeline, and the really very first step is data acquisition. From where you will get the data. If I had to create a mask versus not mask image, yes, I can create the data for myself. But what if I want to create a house price prediction model in California? I don't even live there. I don't even know who are there, how the coordinates there are, what is the range of houses there are, or if let's say I'm moving to a different city and I want to understand that what is the average, a 2 BHK price of a house will be. I can just ask to my neighbors that क्या भाई क्या है average rent this area का. But if I want to create an ML model for that, I would require training data, and from where I will get the data. If you are working in an industry with some firm or organization, you might get some data. But what if during your college period you want to create some ML models? Kaggle, uh, all of you might have heard about competitive coding so far, and all of us would be using CodeChef, HackerRank, and lots of other platforms for competitive coding, right? Similar to create data science and machine learning projects, Kaggle is one such platform from which you can get the data, you can enroll in competitions, you can submit your models, and you can win money on your those models. You can win prizes and medals and cash prizes and whatnot. So Kaggle is one such platform from which you can get the data. Then there are Google data set search engine. The way Google search works and Google Scholar there is for students. Google has launched another service, Google dataset search engine, from where you can get free data, open source data for various different applications. And when I was in my college and was learning machine learning course, I created a project on, one was on face detection, one other was on real-time human gender and age estimation. The other which I created in my computer vision course was human position estimation. So if the person is currently walking, is it going upstairs, whether the person is lying or sitting, so human pose estimation. So for all of those projects, I just served on Google Dataset search engine and get data from UCI hard directory, from Kaggle and lots of other platforms. Or now, if now I'm working in the industry, it's not like that I get like these are 10,000 documents or 10,000 images of apples, use them and create a model in 1 week and let's just deploy it. Industry doesn't work that way. The industry, uh, the data acquisition thing is a really big chunk of what as a machine learning engineer you would, uh, as an ML engineer you would be working on, because developing the applications which I discussed earlier, which I did in my college, the data for that was really uh, perfect to that application. It wasn't containing any noise. But in case of real life data, the images, the videos, the text would be really very noisy. So to get the correct data is a really big step for creating any ML pipeline. Very well, guys. The first step is data acquisition. What should be the next step? Write in the comments again. Whether that should be model deployment, model monitoring, feature engineering. What should be the next step after we have a good enough data on which we can train our model? You guys are fantastic, yeah. This session की ज़रूरत ही नहीं थी. You know everything, yeah. So the next thing is data cleaning, and data cleaning again a very big chunk, because to create a classification model is just a task of a week or two, because you would get the algorithms online, the codes online, and machine learning is always a concept heavy and code light field. So whenever you go deeper into understanding of an algorithm, it might take a month for you to understand just a dimensionality algorithm, let's say PCA, principal component analysis. But then if you want to code using Keras library, you just require a single line of code, and that's it. Whatever you have learned from a month would comprise in that one single line, and that will work. There are open source libraries such as TensorFlow, PyTorch, Caffe, Theano, Keras, and many, many, many other, which you can use uh, for this model training part. In fact, if you do not want to build a model from scratch, you can even use the pre-trained models, the models which are being trained on millions of images, on thousands of class, on good GPU and TPU machines, the deep neural networks, which are developed by great companies and organizations like Microsoft, Nvidia, Google Brain, Facebook Research. Those models can also you can use on your data if you want to create an image classification model on custom data, but you can still use that pre-trained model which was trained on 1,000 classes. Even though you just want a model which can be used to classify mask or no mask, you can reuse that model which Google Brain has developed. But what was the input size of the image in that model? If you are working on text data, what was the clip limit? What was the number of words in each of the sentence in that model versus the model you have? In case of an Excel data, is there any blank spaces or null cells present? If there is, we define that we want the target class, that whether the student will pass the next semester or fail. But what if the data entry operator do a mistake, and instead of writing here pass or fail, he wrote your grade of cloud computing in this cell, he wrote like A plus. So there is not a clean data. You have to look through the input data which you have, then you have to remove this noisy data out of it, and then to create that perfect data on which you can train the model. Okay, so now we have the data acquisition part is being done. We have understood the data, we have cleaned the data. What should be the next step in our ML pipeline? Pranav Gandhi has written model selection. Deepika is also writing model selection. सबका copy कर रहे हो या you guys are really very quick, or you really know the answers? I guess you guys are copying, aren't you? Because the next step is feature engineering. I haven't talked what feature engineering is in this session, like not in the active manner, but indirectly I have told you that, in case of image classification, I asked you all that what are some of the differentiators between these two images. So, whatever you wrote, circular, shape, texture, those things are the features, those things which we as a human understand, that this, if there are two eyes, there is a one nose, and there is a mustache and four legs, there is a cat, and then if the animal which is not using the four hands but is like standing on two legs and the two hands are waving, it is not a cat, it can be a human which has a similar property of two eyes, one nose, and maybe a mustache. So to understand your data now in a deeper and in deeper manner, that is known as feature engineering. To give you one more example, let's say I want to create a model to predict the employee's salary. Okay, I'm giving you an Excel sheet which has 30 different columns, and it has the name of all of the employees, which what is their background, what whether they are BSc pass out, whether they have done PhD, masters, or what their education background, where they currently reside, whether they are in Navranpura or in Vasna, in Ahmedabad, in Bangalore, in Surat, whatever, whether they are married or not, how many children they have, what is the number of years of experience they have. So I will give you this Excel sheet with lots of different columns of that background or for that education, years of experience, that current job role. Currently, are they a data scientist, or is the person is a peon, or is the person is a professor in some XYZ college? Okay, so imagine you have this 30 different columns. Will it be possible to create a mathematical function like first column into 5, second column into 10, and those numbers 5, 10 means weightage, that if the person has studies PhD, then his salary should be higher as compared to peon. Okay, so we understand, we can get these relations by seeing the data, that marital status is not that much important feature for predicting the salary of a person as compared to the years of experience. I just don't care that whether you are married or not, whether you have children or not, whether you are residing in Navranpura or Vasna, but if you have good enough education, if your grades were good, if you have 10 years of experience. So some of the columns are really very important for these particular problem, versus some of the columns are not that much important. So, and segregating these columns from each of them, deleting some of the rows, deleting some of the columns, is known as feature engineering. In case of pizza versus not pizza, like if there is an image which is circular shape, there's a fluffy base, some cheese white colored topping is over there, some red ketchup you can see. So those things are known as feature, which on your data, particular to your data, you have to do. You would also require business understanding for that. I work in the shipping industry. Do you think that I would even know how a cargo moves from one country to another country when I was in college? But the day I joined shipments, I had to learn what are the industry specific terminology, and then how to understand those terminology to a machine, so that can take decisions out of it. So for feature engineering, you would require business knowledge, business understanding, and then only you would be able to understand whatever the input data you have. So yeah, now we are done with data acquisition, data cleaning. We have understood what this data means. If you are working on something like population data or on medical imaging, imagine that you have X-ray images of some persons having coronavirus positive and some having pneumonia versus some with a normal lungs. So for example, you have MRI scan images and you want to understand that whether this MRI scan has brain tumor or not. So first of all, you would have to consult maybe a couple of doctors and understand that what these things is actually, because only after that you would be able to code those stuff or select the particular algorithm. So the model selection thing which all of you wrote is the step which will come next. Once you have the clear understanding of your data and what exactly the output you want, you will select a model. As mentioned earlier, there are tons of libraries, tons of codes available online, but you cannot try each one of them. You can try 5 or 6 different models, but to select which model to train first, for how many epochs, how many number of input images you would require, those kind of stuff. After having the design thing done, now you start the developing thing. Now you select first of all the model and you tune the hyperparameter. Remember the teachable machines screen, the user interface. I opened the drop down box and then there was epoch, learning rate, batch size were returned. So those are the parameters. If you are using a pre-trained model, as mentioned earlier, something I want to use which Google Brain team has developed on my images. But then I just do not want to train my model for, let's say, 6 hours, because I do not have that much computation power, but I just want to run this code for 1 hour. What would the changes I would have to do? I'm not getting the 80% accuracy which my professor has asked me to get. How to tune the parameters, how to change the training data again, how to correct the labels, how to clean the maybe data again, how to get some more data. Because there can be possibility that by using just 80 images of mask image versus 80 images of non-mask image, that online model was able to recognize. But when you will build your first deep learning network or convolution neural network, by using just 80 images, you would not get 100% accuracy. You might get just 20 or 30%. So for that, you would require more data. You might have to train that model for a longer period of time. So all of that go and throw trial and error thing would happen once you have selected your model. And then there will come a 3-step procedure of model training, model validation, and model testing. Okay. So in case this is particular to this machine learning and deep learning field, that whatever the training data you have, this model validation part is not a mandatory thing, but all of the 1000 images you have, you will keep aside, let's say, 200 images from very first day. You will not touch upon those images. You would just use the 800 images. You will do the feature engineering, data cleaning, hyperparameter tuning, everything, model selection, and then you will train your model on those 800 images. And once it has learned from those images, once the professor has taught you something, he or she will take the exams. Similarly, those 200 images which we put aside from very beginning, we will test on that images. Because if we will teach a student everything from day one, we won't left with anything to ask in the exams, right? We want to check the understanding, we want to check the accuracy. For that, we would require some unseen data. So like, it's your choice how you want to split the training and testing data. And this model validation is like, from all the 800 images you had for training, on every epoch, on every iteration of the training, you may want to test again and again. So it's like a weekly or monthly test. You do not want to, you had your model which was supposed to run for 10 hours, and after 10 hours you will get that the model accuracy is 40% and you become upset. But what if on every iteration, on every hour, you want the testing results? So for that, some of the training, some of the images from training, those 800 images, they will be keep aside for testing on every iteration. So that is known as the model validation part. It's okay if you do not understand this terminologies right now, but it's okay. And it's good to know that we should never train our model on testing data set, because then we won't left for anything for checking the real accuracy. Then a model can fail on the unseen data. So Done with model training, model validation, model testing? Let me know in the comments what should be the next state. We are just left with model deployment and model monitoring. Yep, perfect. Model deployment. So now in your local system, on 1000 images, you have your classification model of mask, whether a person is wearing a mask or not. But now you want to create an application or a web app, or if you are working on an industry, you want your clients to use that thing. So there is a whole chunk of model deployment, a big chunk happens. Whether you want to deploy that thing on your local system only, or you want that to be up 24 hours and you want to run from a cloud engine on Google Cloud Platform or on Azure, on AWS, Amazon service, where you want to deploy it. How many computation would that machines, those virtual machines will require? Your computer had 4 GB of RAM, and on testing, it takes like 4 seconds. So once you have trained your image, when you give a single image for testing, yeah, all of the uh, background which goes the once you give the input image, all the model training parts is being done. Your model takes 2 seconds to generate an output. Whether that 2 seconds your client would be okay or not. Imagine a case of self-driving car. If you want to cross roads or not, you will check a traffic light, whether there is a red, a green, or yellow light, and camera attached to the self-driving car captured an image, which was a red sign, or let's say it was a green sign, and then it took like 5 seconds to understand that this traffic signal is currently blinking the green signal. That means I can go, I can cross the road. But the image which was captured before 5 seconds, I'm getting the results after 5 seconds. And what if the signal light got changed during those 5 seconds? So self-driving car, I will set the flag, I will give instruction that you can cross this road, it is open for you. But if it wasn't open anymore, you will get an e-challan, or you might kill someone. So I guess someone's mic is turned on by mistake. Please mute yourself.
Let me
So
just check.
on testing, like how much, for how much seconds you can get the delay, whether it's okay to get a delay or not, where to publish it, where to deploy it, when to use those testing data, the users data again, to train your model, is what model deployment part is. And finally, monitoring. It is not that your job is done once you are doing the deployment stuff. When you go to the industry, you have to keep on monitoring whatever the thing which you have deployed, whether your clients are satisfied with it or not, or whether you want to change something or not. But all of you are still yet to go to the industry 2-3 years, so let's not go into detail for this part. Yeah, so today we understood that what machine learning is, what are the application, what is the basic pipeline for that. And now I guess I have motivated all of you to jump on this field and be the next generation ML, DL, CV, and LP engineers. And you want to do some daring stuff in your life. But I would like to say that learning machine learning is really easy. There is lots of open source courses available. If I talk about myself, before taking the first course in my 5th semester of machine learning at Ahmedabad University, I taught these things to myself using one of the online courses created by Google. And then I taught my batchmates and my seniors during the first pilot of Google's machine learning crash course, which I, along with my seniors, conducted. So I learned ML by myself even before reading any books or stuff. But to be in this field for years, to master this field, it will take a lifetime. So it's not that via using some pre-trained models and some open source libraries, if you are able to generate good results, it's not that you can tell yourself that yes, you are now a machine learning practitioner or a great ML engineer or a researcher. You have to be updated to this field day by day. There is a tremendous amount of research and development happening around the world. You have to be aware about those things. You have to be really very good at mathematics. I spoke earlier, linear algebra, probability, calculus and differential equations, because only if you know that how this algorithm works, then you will get those intuitions and be able to take decisions that whether I should use algorithm X or algorithms Y. So it seems like a lot of people are now working in this field and jumping in this field just because salaries are high. If everyone is doing that, let us also give it a try for this field. But it's not quite true. To be in this field forever, to master that field, it will take efforts which you have to give on your day-to-day basis. And ending of my this ML part, I would like to end with beautiful quote which I like from Sundar Pichai, that AI is one of the most important things humanity is working on right now. It is more profound than maybe electricity or fire. Okay, so the how the world changed after electricity came or after the invention of fire happened by our ancestors. AI has the capacity and ability to change our daily lives, which we are, seeing every day. We are using our smartphones and laptops, and there we are using a hell lot of applications which uses AI ML inherently without even our knowledge. The Facebook, Twitter, WhatsApp, and everything, the social media platforms, online platforms which we use are being based on these algorithms, and they have the power to change the way we live. So before asking you all and opening the Q&A session for ML, as promised earlier, there is some surprise topic for you all, which I haven't even asked to the organizer of a P Club and Yash Raj that whether I should take this or not. But I guess the thing which is not that much in our, okay, so this is particular to because I want our university, the university from which I graduated, I want those students to be good in their lives. I am just promoting this thing and making you guys aware that what Google Developer Student Club is all about. I told you that I started learning ML by myself, and if you might have know me from earlier, or if you have heard the introduction given by Yash Raj, that I have had an opportunity to be at global stages to give tech talks on very dense and different topics of ML and DL at London. Last year I went in the Most Fest. This year I had an opportunity to go at Ohio, and not just in Ahmedabad or such webinars. I have been to different cities of India as well, just to talk about machine learning. Isn't that a cool thing? To teach others, to create content, to write blogs, to create videos of that. But moreover, I even know that once we conducted the MLCC pilot, now there are some of the facilitators who are conducting ML beginner and intermediate sessions at School of Engineering and Applied Science. There is a very good progress programming club is doing. But if we see how many teams from your batch went to a same ICPC last year or are planning to go this year, they still are not that good in coding, or not like their you may find 5 or 6 different students in your batch who are really good at competitive coding or developing backend or front end or mobile application. There can be a set of students who are really good in applied CS with Android cores and can create any of the mobile application, and maybe Kotlin and Java and Flutter, um, using different languages, but you don't know those stuff. So the stuff which industry requires, the networking skills, the communication skills, and then back and front end, the technology stack, which we do not get to learn during our college, during the 4 years and 8th semester of a college. Still having a project-based learning, which is one of the really good thing which Ahmedabad University propose, but to have more advancement and to get benefit of the resources are out there. I have got the opportunity to be the one of the very youngest GDE from around the world and the first GDE in ML in Gujarat. So I did this in really early age. When I now see the other Google developer experts, they are like 10 and 13 years of experience having. They have written research papers, they have written books by their own, and now they have become GDs. While on the other side, I having just 1 year of experience, I just passed out in 2019, and I got an opportunity to be a GDE. Why? Because I started my community contributions earlier. I started my journey of ML earlier as compared to most of the other students. It's not just limited to machine learning. If you are passionate about backend or cloud technologies, here I am in front of you giving you talk because just that I am an alma mater of Ahmedabad University, and I would love if the students of this university do better in future. But what if you want to contact to other GDs? What if you want to network with Googlers? What if you want to invite Googlers to our college to give sessions to make you guys aware about the recent trends? So this is one of the very good initiative from yours by Google, is Google Developer Student Club. And if we can establish this club in our university, the students of our university will get really good benefit from the community out there, from the Googlers out there, from other experts out there. And then they have, DSC's India lead. They have like 3 to 4 days of summit. Last year it was in Goa. So you get a whole funded trip to Goa, not a trip, but networking and understanding educational trip. And then you can network with all the students and all the professionals out there. In Ahmedabad, just near my university, has this club, and I really encourage all of you to apply for having Developer Students Club at our university. If at all you are interested, you can apply to be a lead. So maybe Ashraj is the lead for programming club right now. And if you are in second or third year and you want to be a lead for the GDS DSC group, then there is an online application which you can apply, and then we can establish this club in our university. Feel free to reach out to me anytime if you are interested taking this leadership initiative. Go to this website to learn more about this club. I have attached a video with this presentation which you guys can go through by your own. And let me know if you want more support, you want to be connected with the Googlers who are leaders of these DSC clubs, who are managing this stuff in India, with whom you want to connect, you want yourself to get introduced. I would be more than happy to help you for that. But the coding and real life applications experience, which would you get from these clubs by networking, by communicating. So do start that from early ages. I don't know if you know about Google Developers Group, GDG, Ahmedabad which is present in for specifically women out there, all the female students. There exists Women Tech Makers WTM group in Ahmedabad as well. So the way I am speaking right now in front of you, I have given talks at GDG and WTM as well. So they organize monthly meetups on different technologies, not just ML data science, but on cloud, web technologies, and products also. So imagine you get to learn all of these things from free, and you get to meet two new colleagues. You can create more friends out there, and then you can have projects with them as well. So my piece of advice for you is to be good in life, to be good in an industry. The importance of technical fields, the importance of technical knowledge is there, but similarly the importance of communication skills, the networking skills, the intrapersonal skills, the teamwork skills are also that much important as compared to your technical skills. So these initiatives, going to these meetups, leading these DSC clubs at Abbey University would help you grow yourself in a whole manner. And yeah, please do reach out to me if you want further information about this thing. So I hope in next couple of months we may have this DSC club at AU, and most and like we have almost 2 hours now. Thanks a lot for all your patience listening to me. We discussed today about what is ML, what are the applications, how you can kickstart your journey. I discussed a lot of different applications. So, many of the students come to me that I have understanding of this field, but I don't know what project I should start with. I gave you a lot of different examples which you can start with. So do kickstart your journey in this field. Do reach out to me on Twitter, GitHub, LinkedIn whenever you want. Feel free to follow me and connect with me. Thank you. Happy learning. I would like to get, if any questions you might have, any suggestions or comments you might have regarding my session, I would be happy to answer them. Over to you, Yashraj and the team.
Thanks a lot, Chami, for this beautiful session. I'm sure it was a delight for the participants. Let's if there are any questions, as Chami said, please type them in the chat. We can wait for a minute or two at least for the first question, and then we can move on to the wrap. I think the session was very clear, and there should not be a lot of questions, but let's still see.
Yeah. Perfect. Thanks, Aditya, for the kind words. Happy to know that you liked the session. Pranav Gandhi is asking that what are the steps for beginners to learn ML and what are the sources? Okay, I'll share some of the sources with the PClub team, which they can forward to you guys. But as mentioned during my session, you can get a hell lot of online courses on Udacity, on Coursera, which I do prefer and which from where I have learned, and the other platform is deeplearning.ai. There are a lot of courses on other this MOOCs like Udemy or Unacademy, and there are a lot of others. But do visit Coursera if you can. You can get free content from there, and you can learn from the professors from MIT, Stanford, Brown University, and lots of other. So sources are just simple. Google it out. There are a lot of different YouTube channels. Start reading books, and to start your journey with ML, the very first thing which I mentioned, that if you want to go to the research area of ML, Mathematics is what you would be required to be good at if you just want to be into the application field, where you just want to always use some pre-trained models. You don't want to go into the deeper how those things, how those algorithms works. Then you may directly start with any of the projects. Create your user on Kaggle right now, just today, and start with the Titanic question, the problem, where you would get the data out there. You can see other person's code out there, and then you can start your whole journey with ML. But yeah, to be good at mathematics is one of the important things. And then one of the languages you should have a basics understanding of that, like Python or R. Machine learning can be written in C++, in C, in Rust, R, Go, in a lot of different languages as well. But Python and R are the most used in industry or in research. Julia, if you have ever heard of a very recent and um, very young programming language, Julia, which has very similar, coding style as of Python, but has the power of C. So it's as fast as C, and it has the interpretability as easy as Python. It works 3x times faster in some of the cases. So like matrix multiplication and all of these things you would be doing in your subsequent semesters, and then you would understand that how much complex can be matrix multiplication of those images. So for that, be good at mathematics, be good at one of the programming languages, and do internships. I did two internships when I was in my bachelor's, and then I got my first job as a machine learning engineer due to my those profile and my projects. So yeah, that would be my advice. Now the next question from Videsh Joshi is that I don't have questions on ML. I am seeing a link of Medium stories on your bookmarks tab. Are you writing that? Okay. Yeah, Videsh, I have written a couple of blogs on that. Yeah, some two of them are okay. So thanks, Yash, for sending that Medium link of mine. So yeah, very recently I have started my blog writing journey. I have written 3-4 different blogs which you can read by your own. So yeah, anyone else, if you have any questions regarding anything, feel free to ask me here, or in future you can connect with me on Twitter, LinkedIn, GitHub, or my email ID is just simple charmichokshi@gmail.com. Yeah.
Hello.
Yes.
Yes, sir. So I think the questions are set.
Okay.
I think we're done with the questions.
Hmm.
Uh, Actually, I had a question. Like, I'm not
Mhm.
sure if it's covered in the session or not.
Hmm.
Do you like sort of need like can you pursue a career in applied machine learning as a fresher, or do you like as a bachelor, or do you need a master's or something like that to be considered for good positions?
Hmm. Good questions, Yashraj. Thanks for asking me. This can help a lot of other students as well. So, giving just my example, yes, I am working in the applied field of ML just after completing my bachelor's. So, yes, it is possible to be a ML engineer right after your bachelor's. But to be in a good firms like Google or Facebook or Microsoft, most of them do require masters, or many of them do require PhD degrees as well. But if you have a good profile, you have a good grades, you have good projects and internships in your hand, even Amazon's applied ML role is one where you can apply. So if you have good understanding and portfolio of this field, there is no boundary for you. Even I had uh, given two Google interviews, which were not of ML field but of a software development field, and unfortunately, I didn't get to pass those. Even I had one Google interview when I was in my fourth semester, I guess. So Google had reached out to our college, and there I was one of the candidates who gave some of the interviews. So if you have, good profile, those companies are always in search for good candidates. And if you have good understanding, you have published maybe some of the papers or have done good projects and internships, there are numerous opportunities for you. But if you have like not so engaging, or you are not an anomaly from the mass, then having a master's is a plus point, because once you have an MS degree or a good MTech degree from India, from IIT or triple ITs, those good organizations would reach out to you on campus, and then you can get recruited by them. So yeah, there is no hard line that being a bachelor you cannot be at a Google or at Amazon. But yeah, you have to be at good what you, and you should know what you are doing. So yeah, I hope I give you
Definitely, yes.
yeah
It was a
clarity
very
of
detailed
this.
and a very very clear answer. Thanks a lot, Charlie, for coming today and spending your time with us, like spending a Sunday evening with us.
Yeah,
uh, I'm sure the participants enjoyed the session very much, and their decision of attending the session was worth it. We'll
right.
request you to share the slides as well as the
Definitely, yeah.
resources at your convenience, and we'll happily forward
Yep.
we'll forward them to the participants.
Yeah.
And
Sounds good. Perfect.
I think then that's a wrap. We hope to see you around next time for maybe something else, for some another event that we guys aim to do. Thanks
Sure.
for the small surprise that you had about the developer circle. Uh,
Yeah.
Thankfully, like two of our friends at Programming Club have applied to become DSC leads. So let's just hope
Okay.
at least one of us makes it and we get a DSC. And
Yeah.
with with the tagline of Google, probably we'll be able to do more and reach out to better people.
Right.
Yes, so that we are really thankful that some seniors pointed this out to us and we applied before the deadline. And we
Right.
also had our interviews. So let's hope it goes good.
Yeah. All the best, everyone, for your bright, bright, bright future ahead. And feel free to reach out to me anytime. I would be more than happy to help all of you. And yeah, please to get start your community journey, do go to the meetups, and I would be really happy to help you to establish a DSC chapter at our college. Because after going to the industry, when I chat with some of my batchmates or some of my seniors, I get to know that what are the things we missed doing during our bachelors, which we don't want you guys to suffer from. So this DSC club can be one of them. And uh, once I share you the deck, do share check the videos and do go to the website to know more how the DSC chapters in India and Gujarat around the world are doing, and what as a student you can contribute to the society. Thanks a lot for inviting me today. Good luck, everyone. Have a nice whatever the Sunday left today. Thank you.
Thanks a lot, Charmi. Guys, her LinkedIn link I have dropped in the chat. Do check it out. Get inspired. Connect to her. Talk to her. I'm like she's very very active there. I've seen. Uh, so I think that's about it, guys. Thanks a lot once again, Charmi, for coming. It's like
Um,
the helpful nature of our alumni that is benefiting us juniors a lot. Like I have
right.
seen that you guys are like you guys give back a lot to the community and especially to Ahmedabad University. So
Hmm.
that's really amazing. Thanks guys. Thanks a lot for coming. Thanks my friends at Programming Club. Uh, because we are able to do a lot of events in this summer vacation because uh, and we are also getting good participation, so that's very nice.
Yeah.
So that's about it,
Great.
guys. Thanks a lot.